All right, let's dive into what might be the greatest detective story of all time, the hunt for life beyond Earth. We're going to be the cosmic detectives today, looking at the clues, the tools, and the suspects in a mystery that stretches across the entire galaxy. So, where does an investigation this massive even start? It all comes down to this one question, doesn't it? Are we alone? For thousands of years, we've just stared up at the sky and wondered. But here's the amazing part. For the first time ever, we have the tools to actually investigate. This isn't just philosophy anymore. It's a real, evidence-based search. For the longest time, our list of suspects was pretty short. We just had our own solar system with planets like Jupiter. But then, everything changed. Thanks to telescopes like Kepler, we've discovered that the galaxy is absolutely packed with planets orbiting other stars. These thousands of exoplanets mean our list of potential crime scenes has just exploded. The game is on. Okay, so first things first. Before you can look for life, you have to find the planets. And trust me, that is not easy. Imagine trying to spot a firefly buzzing around a searchlight from hundreds of miles away. That's kind of what we're up against. So how on earth do we do it? Well, cosmic detectives have some pretty clever tricks. The first is the wobble method. As a planet orbits its star, its gravity makes the star wobble just a tiny bit, and we can detect that. Then there's the dip method, my personal favorite. We just stare at a star and wait for its light to dip ever so slightly as a planet passes in front of it. And finally, we can even use gravity itself as a giant cosmic magnifying glass to spot a planet. Each method is a tool in our kit to map out where the suspects are hiding. Okay, so now we have thousands of planets. We can't possibly investigate every single one. Any good detective knows you have to prioritize your leads, right? You focus on the most promising locations. And for astrobiologists, that means looking in a very specific neighborhood. And that neighborhood is called the habitable zone. The whole idea is really simple. As far as we know, life needs liquid water. It's the one non-negotiable. So the habitable zone is just that sweet spot, not so close to the star that all the water boils away, but not so far that it all freezes solid. Yep, it's the Goldilocks zone. Not too hot, not too cold, but just right. Any planet we find in this special region immediately becomes a prime suspect. These are the worlds we're going to put under the microscope, searching for the most critical evidence of all, the fingerprints of life itself. So, let's say we've found our suspect, a planet, in the Goldilocks zone. Now the real forensic work starts. We need to look for what scientists call biosignatures. These are the telltale signs that life is there, actively changing its environment. We're literally hunting for cosmic fingerprints. And these clues fall into three main categories. First, we've got gases in the atmosphere. What's the planet breathing? Second, there are surface signatures. What does the planet look like? Has life painted the surface? And third, there are temporal signatures. Does the planet show patterns like seasons that hint at a living world? Let's kick things off with the atmosphere. Think about it. A planet's air can tell you a ton about what's going on down below. And looking for these gaseous signatures is one of the most powerful techniques we have for searching from light years away. So how do you read an atmosphere from across the galaxy? It's genius, actually. When light from the planet's star shines through its atmosphere, different gases soak up specific colors of light. This leaves a unique pattern, like a barcode. Every gas, oxygen, methane, you name it, has its own barcode. So we can scan that light and get a complete chemical inventory. And here is where the detective work gets really cool. A dead planet's atmosphere is usually pretty boring. It's in what's called chemical equilibrium. But life is messy. Life is active. Just look at Earth. We have lots of oxygen and a little bit of methane. Chemically, these two gases shouldn't be together. They destroy each other. The only reason they both exist is because life, from trees to microbes, is constantly pumping them out. Finding that kind of disequilibrium on another world, that would be a huge sign of a living, breathing planet. Okay, an atmosphere gives us fantastic clues, but it's not the only place to look. What if life literally changes the color of its world? What if it paints its own fingerprint right onto the surface? Think about a plain old rock. It reflects sunlight in a pretty smooth, boring way. But life on Earth does something really weird. Plants absorb red light to do photosynthesis, but they reflect near-infrared light like crazy to stay cool. This creates a huge, sharp spike in the light spectrum called the vegetation red edge. It's a planetary scale fingerprint of our forests. Finding a red edge on another world would be an absolutely electrifying discovery. But hold on, every good detective story has a plot twist, and in this story, the twist is that nature is really, really good at faking evidence. We can't just assume every clue points to life. There are cosmic red herrings everywhere. And this is maybe the most important rule of the entire investigation. Just because you find a gas that life can make, doesn't mean life did make it. As this quote says, context is everything. You have to understand the whole planet, its star, its geology, everything, before you can say for sure that a clue is real. This is the million-dollar question for any alien hunter. How do you make sure you're not being tricked? How do you prove beyond a reasonable doubt that what you're seeing is actually life and not just some weird, non-living chemical process? Let's take oxygen as a perfect example. On Earth, it's the ultimate sign of life. But you could get a planet loaded with oxygen without a single living thing on it. Imagine a watery world getting blasted by intense UV light from its star. That light can literally rip water molecules apart into hydrogen and oxygen. The superlight hydrogen just floats away into space, but the heavier oxygen gets left behind. And bam, you have a planet with an oxygen-rich atmosphere, a total false positive. And that's exactly why this whole search isn't about finding one single smoking gun. It's about building a case. A good detective needs multiple independent lines of evidence, all pointing to the same conclusion while also ruling out every other possibility. Now, here's the best part. This investigation is really just getting started. We are right now, at this very moment, entering a golden age of exploration with incredible new tools that are going to completely change the game. Our magnifying glasses are getting so much more powerful. The James Webb Space Telescope is an absolute game changer. It's giving us the ability to read those atmospheric barcodes with a kind of detail we could only dream of just a few years ago. It's already taking this detective story from theory to actual real-world observation. And the cavalry is coming. In the next few years, enormous new telescopes on the ground will join the hunt. And looking ahead to the 2030s, we're designing new space telescopes that could, and I mean this seriously, take the first actual photograph of another Earth. Just think about that for a second. So the ultimate goal isn't just to find one clue. It's to build an airtight case that can stand up in the court of scientific opinion. It means understanding a planet so completely that you can methodically rule out every single non-biological explanation until life is the only suspect left standing. Finding life, even just simple microbes on another world, would fundamentally reshape our understanding of the universe and our place in it. It would be profound. But it makes you wonder about the other possibility. As our tools get better and our search gets deeper, what if all we find is silence? What would that quiet tell us about how precious and maybe how lonely our own living world truly is?